Hello everybody, I welcome you all to NCAS Geology class. Today I will discuss about the crystal projections, how the crystals of different systems can be projected into the stereogram, or how can we project the faces of the crystal into the stereo net. That I will discuss. So, a crystal projection is a means of representing the three-dimensional crystals on a two-dimensional plane. We have the crystals which are three-dimensional, but to represent it in a two-dimensional plane, we adapt certain methods, and that is called crystal projections. And there are two ways by which we can project the crystals. One is the spherical projection, the other is stereography projection. So let us discuss these two methods of projection, that is spherical projection and stereography projection. So what is spherical projection? In case of spherical projection, the crystal model is assumed to be located within a sphere, so that the center of the crystal coincides with the center of the sphere. Or if the crystal is lacking a center of symmetry, in that case the meeting point of three crystal axes or four crystal axes is taken as the center of the crystal, and that should coincide with the center of the sphere. Then perpendiculars are drawn from the center of the sphere to the faces, and these perpendiculars are extended to touch the sphere from the inner side. The points where these perpendiculars join the sphere provide the poles of the faces, and these poles together form the spherical projection of the crystal concerned. That has been discussed here. So, in order to have a spherical projection of a crystal model, first the model is imagined to be located within a sphere, so that the center of the crystal coincides with the center of the sphere. In case of crystals lacking center of symmetry, the meeting point of crystal axis is considered. From there, the perpendiculars are drawn to the faces. The perpendiculars are erected from the center of the sphere to the crystal faces and are extended to touch the sphere from the inner side. The points where these perpendiculars touch the sphere locate the poles of the faces, poles of the corresponding faces. These poles together they form the spherical projection of the crystal concern. And here the poles which are plotted in the sphere, they can be described with respect to their angular coordinates with the sphere, and these angular coordinates is similar to the locating of places on the earth surface through latitudes and longitudes. Latitudes are great circles placed east-west with the biggest circle at the equator, and the higher latitudes are smaller circles measured from the equatorial plane in degrees along north-south to locate latitudes ranging in values from 0 to 90 degree. Similar longitudes are all big circles, all great circles They are equal in length with orientation north-south and pass through north-south pole with zero meridian at Greenwich, and from it longitudes are considered east-west up to 180 degree to locate the places on the Earth's surface. So, the poles that we plot in the spherical projection, they show the angular relationship which is similar to the latitudes and longitudes of the Earth, that we take into account in order to look at the places on the Earth's surface. So, this has been shown here. This is the globe, this is the equatorial plane, this is the center. So, if this is a place is here, so from the equatorial plane we join the center of the equator to that place, and how much angle this line makes with the equatorial plane, that gives the latitude of this place. So, latitude is same latitude is it is a circle. This is latitude is a circle. So, if it is 50 degree north latitude, this will be say 80 degree north latitude, and here it will be 90 degree north latitude. Similarly, on the southern hemisphere we have the 70 degree south latitude, 80 degree south latitude and 90 degree south latitude. So, latitudes are circles, complete circles, and the bigger circle is the equatorial circle, and smaller circles are the higher latitudes. Similarly, we have the longitudes. We have the zero longitude passing through Greenwich. This is the half circles, but these are called the great circles because these are the parts of a, it can be considered as the parts of a great circle. So, the arcs. So, these are called as great circles. So, great circles, they represent the longitudes of a place. Zero longitude is the Greenwich longitude, and from that towards east and towards west we have 180 degree, up to 180 degree we locate the we have the longitudes east, along east and west direction, and so each place is having certain latitude and certain longitude. Similarly, each face on this sphere, each pole of the face that can be located or that can be identified on the basis of its angular coordinates. Angular coordinates will be either phi angle or will be the rho angle, that I will discuss what is rho, what is phi. So, the poles of the faces that we plot in the spherical projection, that is similar to latitudes and longitudes of the places that we show on the globe. So, if we take into account a place with 0 longitude and 50 degree north latitude, it will be located at this A place. 0 longitude and 50 degree north latitude, because this line, the 50 degree north latitude, and this line is the 0 longitude. So, this is the intersection point A. Similarly, place B, the place B has 50 degree north latitude. So, this is the 50 degree north latitude circle, and it is this longitude is the 20 degree longitude. So, 20 degree east longitude. So, the point B on the globe is having 50 degree north latitude and 20 degree east longitude. So, the poles of the spherical projection is having the angular relationship that can be similar to the latitudes and longitudes of a place on the earth surface. There is only a little difference. There is one major difference between the locating points on the earth surface and that on the spherical projection. What is that? That is, on the earth, the latitude is measured in degrees north and south from the equator, whereas the angle which are used in spherical projection is the co-latitude, or it is the polar angle. With respect to pole, how much is the angle, which is measured in degrees from the north pole. Thus, the north pole of a crystal projection is at a co-latitude of 0 degree and the equator is at 90 degree. That is reverse of a place on the globe, because in latitude north pole is 90 degree latitude, equator is 0 degree latitude, but when you talk about the spherical projection, north pole represents 0 degree, latitude 0 degree and equator is 90 degree. So this is the difference. Otherwise, the angular relationship is similar to that we see in case of latitudes and longitudes. So we can take into account the angles. The angles are described in terms of rho and phi, that I will discuss. So the co-latitude angle is designated as rho. This rho in crystallography, and the crystal longitude of the pole of a face on the spherical projection is measured just as are longitudes on the earth. They are measured in degrees up to 180 degree clockwise or anti-clockwise from the starting meridian, which is 0 meridian, analogous to Greenwich meridian in geography. Similarly, we have the zero longitude passing through the pole, which is occurring at 010 phase. The point where 010 phase appears on the spherical projection, that pole is considered to be the starting point, and through which the vertical circle that runs is the 0 longitude. So to locate the starting meridian, 0 meridian and the crystal projection, the crystal is oriented in conventional manner with the 010 phase to the right of the crystal. The meridian passing through this pole of this phase is taken at the 0 meridian. Thus, to determine the crystal longitude of any crystal phase, a meridian is passed through the pole of that phase, and the angle between it and the 0 meridian is measured in the plane of the equator, or we can say it is the plane of the projection, equatorial plane of projection of the sphere, and this angle is designated by the Greek letter phi. So phi represents longitude, rho represents longitude, but the rho measurement is just reverse to that of the latitudes. So by taking into account the rho and phi, it is possible to project the crystal faces into the stereo diagram. So what is, so in spherical projection we simply project the poles of the faces by erecting the perpendiculars from the center of the sphere to the faces and extending them to touch this sphere. The point of their intersection with the sphere represent the poles. So the poles together they form the spherical projection of the crystal constant, and these poles they retain the angular relationship. In that angular relationship can be described in terms of rho angle and in terms of phi angle. Now let us discuss what is stereo projection. The stereo projection is obtained from the spherical projection. So first we have to imagine how spherical projection is being made, and then from spherical projection how we can go for the stereo projection, that I will discuss now. So in stereo projection this projection is deduced from the spherical projection. It is the projection of the poles of the faces to the equatorial plane of the sphere. To achieve it, the poles of the upper hemisphere, including those which occur on the periphery of the equatorial zone, are joined to the southernmost end, that is south pole, through lines. The points on the equatorial plane where these lines pass are the locations of the projections of the poles of the faces. These are designated by their phase symbols, and that these phase symbols, when they are plotted to the equatorial plane, they together form the stereographic projection of the concerned crystal. So in this process we find that all vertical faces parallel to north-south pole are represented by points on the periphery of the equatorial circle, and all faces which are horizontal, they are represented at the center of the equatorial plane. Similarly, all faces which are neither horizontal nor vertical are represented by points inside the equatorial circle. All faces which lie in one zone. What is zone? Zone, crystallographic zone is defined as the zone where the faces have their mutual edges to be parallel. So in a zone we have a number of faces and their edges are found to be mutually parallel. So all the faces which lie in one zone are represented in one circle or in one arc or in one straight line. All the faces of the crystal which occur in one vertical zone are represented on a straight line through the center of the equatorial circle. The faces which are vertical parallel to north-south pole are represented by the points on the periphery of the equatorial circle. And this relation, the relation between the spherical and stereo projection, that can be shown in a diagram that I have drawn here. So this diagram will show how the spherical projection is converted into stereographic projection. So we have the equatorial plane which divide the sphere into two halves, the upper half and lower half. In the faces which occur in the upper part of the sphere, including that which are occurring in this peripheral zone, they are being transferred to this plane. So this is the equatorial plane, this is the equatorial plane, or it is the plane of projection. So let us say this is one vertical zone where we have these are the faces, these are the faces, these are the faces. So when this face is having symbol 0, 0, 1, top face. When this is horizontal, this face is horizontal. When the pole of this face is lying here. So when this pole is joined to the south pole, it passes through the center. So this is the point of projection of this pole. Similarly, all the faces which come over this vertical circle, they are transferred to this line. So all the vertical circles passing through the center of the sphere, they are represented by straight lines. So this is a straight line. This is a straight line. So all the faces which occur in one vertical zone, they are transferred to their poles. When they are joined to the south pole, they occur in one straight line. And the inclined planes, if the planes are inclined like this, inclined, if the faces occurring in inclined plane, if they are joined to the south pole, they will occur in an arc. So the faces which are occurring in one zone, but they are not vertically arranged, if they are inclinedly arranged, they will occur in one arc. So the faces may occur in one straight line, or in an arc, or the faces may occur in this zone. In this zone. So in this zone, the faces which are vertical, they occur in this zone because they are parallel to this polar axis. So they will be represented along the periphery of this. This relation has been shown here. Let me make it more clear. If we have a cube, cube is located within a sphere. The center of the cube is coinciding with the center of the sphere. So first we have to go for spherical projection. So spherical projection is the projection where the perpendiculars are drawn from the center to the faces of the crystal and extended top to touch the sphere. So these are the perpendicular to the faces. These are the perpendicular to the faces. These are perpendicular to the faces. Perpendicular to the faces. So these are the points where these perpendiculars touch the sphere. So now these 6 points in the sphere, they represent the projection of these faces, crystal faces. Crystal is cube. So cube faces are transferred to the sphere, and in order to, so these faces of the cube, they form the spherical projection of the cubic crystal. So now we will convert it into stereographic projection. In order to draw the stereo projection, we have to imagine a plane at the center of the sphere. So into this plane we will transfer these poles. So in order to transfer these poles are joined to the south pole. So these are the joined to the south pole. So we can see that in the circle, these vertical faces they occur. These vertical faces they occur in these. So these are the four vertical faces. They occur. They occur in this peripheral zone. They are connected to this point. So this is 0 1 0 phase. This is 0 1 bar 0 phase. 1 bar 0 phase. 0 phase. 1 0 0 phase. They occur at the periphery of this equatorial circle, because they represent the vertical faces, the faces of the vertical faces which are parallel to the north south pole. They occur here in the periphery, and the vertical face and the horizontal face, whose pole is occurring just vertically above the south pole, if that is joined to the south pole, it will pass to the center. So the center point will be the projection of 0 0 1 phase. So this is representing 0 0 1 phase. So 0 0 1 phase will be at the center. So this pole cannot be represented. So all the poles which occur in the peripheral zone and that on the upper part of this upper hemisphere, they are transferred to this equatorial plane. That has been discussed here. So we can get the 5 faces in this equatorial plane. For this cube, we have these 5 faces which have been transferred to which have been projected into the equatorial plane, or we can say the stereographic projection of the cube is these faces. So this is the projection of the cube. So that has been discussed. So the relation between the spherical projection and stereo projection are shown in this diagram. So this is one vertical circle, and this is represented as a straight line. This is the straight line. The faces occurring in this zone, they are transferred to this line, and this circle is the locus of all faces which are vertical. Vertical half circle is represented as the all vertical half circles. This is vertical half circle. This can be a vertical half circle. So this vertical half circle is represented by a straight line. This is the projection. So all vertical half circles, they are represented by straight lines in the plane of this is the plane of the projection or the plane of the equator. In the equatorial plane, this is the equatorial plane of projection, and in this plane we plot the faces which are vertical. If this is if these are the cube faces, so poles are done like this, poles are done like this, poles are done like this, poles are done like this. So these 4 poles, they occur in the peripheral zone. So when they are connected to the south pole, they occur there itself. So we see that this periphery zone is the locus of all faces which are vertical, and the inclined circle, they represent the inclined planes through the center, which are not vertical, which are not horizontal. Horizontal faces will occur at the center. Vertical faces will occur at this periphery zone. And inclined planes will occur in inside this circle, not at the center, not at the periphery, but inside. So inclined circle through center of sphere is represented as an arc on equatorial plane in stereographic projection. So this is a cube has been shown here, around which a sphere has been. So this is the cube. So perpendiculars are drawn to the cube faces. Perpendiculars are drawn to the cube faces, and when these faces are linked to the south pole, these are the faces that are projected into the equatorial plane. Perpendicular to the cube face from the center extended to touch the sphere to form the poles of the corresponding faces. Here that has been shown, and this equatorial plane has been brought over here. So this is the equatorial plane of projection. When the poles of the faces of upper half are joined to the point B, south pole, southernmost point, through lines, the points of intersection of such lines in the equatorial plane constitute the projection of the concerned cube faces. So upper 5 faces except bottom are represented on the equatorial plane. So upper 5 faces, the top one is at the center. All the 4 vertical faces, they occur on the 4 ends of this equatorial plane. In practice, the poles of the faces of crystals are directly plotted on the stereographic projection. It is therefore necessary to determine the stereographic distances in relation to the angles of the spherical projection. We can draw this stereo net by taking into account the distances corresponding to the angular relation. The figure below is a vertical section through a spherical projection of a crystal in the plane of 0 meridian, that is the plane which is passing through the pole of 0, 1, 0 phase. Let us imagine that this is a section through a sphere. This is passing this section through a sphere. This is a great sphere, and in the sphere this is section. This is a vertical section, and this is passing through 0, 1, 0 phase, pole of the 0, 1, 0 phase, and conventionally this phase is taken as 0, it corresponds to 0 longitude, and so this is section vertical. This is vertical section. If we say this is the crystal vertical section, the center of the sphere, center of the crystal, perpendiculars are drawn to the faces. They are extended to touch the vertical circle. So here this is the point of intersection. This is the point of intersection, and this is the horizontal face. So this will be vertical, indicating the 0, 0, 1 face, north pole. So this angle, this face is represented as 0. this face is plotted over here, and this face is plotted over here. So this angle between this north pole and this face, so this angle is described as rho. So this face is having rho angle with this face. So this face, this is the face, this is the perpendicular, this is the face, this is the perpendicular, and this line the zero line, and how much angle? This is the rho. And we have taken the vertical section through this spherical projection and the southernmost end. So this is the radius, this is the radius, and if this is rho, this will be rho by 2, this will be rho by 2, this will be an isosceles triangle. This is radius, this is radius, this is the base, and this is the external angle, this is rho. So this will be rho by 2, this will be rho by 2, and this point, when it is connected to the southern point, this passes through the equatorial plane at this point D dash. If it is D point, it passes through D dash. So OD dash can be described in terms of this angle rho by 2. That has been, so OD distance, OD1 distance, that can be found out from this relation that has been discussed here. So in practice, the poles of the faces of the crystals are directly plotted on the stereographic projection. It is therefore necessary to determine the stereographic distances in relation to angles of the spherical projection. The figure below is a vertical section through the spherical projection of the crystal in the plane of 0 meridian, that is the plane containing the pole of the 0, 1, 0 phase. This is 0, 1, 0 phase. This is a vertical section. This is the trace of the equatorial line. This is the trace of the equatorial line. So this is vertical plane through 0, 1, 0, 0, 1, 0 pole. O is the center of the projected crystal. Let us consider the phase 0, 1, 1. This is 0, 1, 1 phase. So OD is the perpendicular to 0, 1, 1 phase. This phase, this is 0, 1, 1 phase. So OD is the perpendicular to this phase, and it touches the sphere at this point, at the point D. So D is the pole of 0, 1, 1 phase on this spherical projection. The line from the south pole S and D intersects the trace of the plane on the equator at D dash, because in stereo projection we have to join these poles to the south pole. The point where these lines pierce the equatorial plane, that gives the stereo projection of this face on the equatorial plane. So D dash is the point where D is being represented. So D dash is located in the FG line, which is the trace of the equatorial plane is like this. So it is the trace of the equatorial plane. So FG at D dash, it joins the FG trace of the equatorial plane at D dash, which is the stereographic pole of the phase 0, 1, 1 of this spherical projection. The angle NOD, the angle, this is north pole, NOD, this angle is called as rho. In order to plot D dash directly in the stereo projection, it is necessary to determine the distance OD dash. This distance we have to measure. Determine O dash in terms of angle rho, because triangle OSD, this OSD triangle, OSD SD, this triangle, the isosceles. ODS is equal to OSD. OSD, they will be equal to rho by 2 because this angle is rho. This angle is rho. So this will be rho by 2, this will be rho by 2. Because this is the radius of the spherical projection. This one radius, R. So OSD will be rho by 2. Then we want to find this distance. So this is a right angle triangle. Hypotenuse. These are the two perpendiculars to each other. So OD dash can be found out from that. Tan rho by 2, this tan of this angle will be P by B. This is P, this is B. So it will be OD dash by OS. OD dash by OS is equal to R. So OD dash is equal to R tan rho by 2. So OD dash can be found out from this relation R tan phi by 2, tan rho by 2. So we can construct this angular distance. We can prepare the net. We can describe the angular distance in this direction. So the net has been prepared by taking into account the rho angle and the phi angle. So in addition to determine the distance of a pole, in order to find out the distance of a pole, or the projection of the pole on the equator plane, the pole should lie from the center of the projection, and it is necessary to determine its longitude or phi angle. So to locate a face, it must have its rho angle, it must have its phi angle. Because the angle phi is measured in the plane of the equator, the plane of stereo projection, it can be directly found out by means of the circular protractor. We can describe in terms of, we can describe phi in terms of the circular protractor. First, it is necessary to make zero meridian, the pole of the face 0, 1, 0. This is, first we have to find out the zero meridian, 0, 1, 0 face. So latitude or rho angle can be plotted, OD dash will be plotted like this in this triangle, and longitudes will be plotted in this side, on this side. So these are the phi angle can be measured clockwise positive or anti-clockwise negative in the primitive. So this is the, if this is the primitive circle, phi angle can be measured in this direction, phi angle can be measured in this direction. So this will be part of the sphere. So this is 0 longitude, 0 meridian. Similarly, along this point 10, 20, 30, 40, 60, 60 like this, it will be, so these are the lines, these are the point, these are this, these will be the longitude. So 10, 20, 30, 40. So along this circle we will get the phi angle. This side is positive, this side angle will be the negative. So in stereo diagram, this has been, or the stereo net has been prepared by taking these angles into account. So rho angle and phi angle they have taken into account, and the stereo diagram, stereo net has been prepared, by virtue of which we will be able to represent the crystals in the stereo diagram through their poles of the faces. So from this point, the angle phi can be measured clockwise positive or anticlockwise negative in the primitive circle from 0, 1, 0 point, which is 0 longitude, 0 meridian, 0 longitude. And the stereo nets have been prepared by taking these values of phi and rho. The net which is used to project the data of crystal faces in stereographic net is called the Wolf net, or it is equal angle net. So if we see any Wolf net, it will be like this. It is the equatorial plane. This will be north, south pole. This will be east. This will be west. And we have the circles like this. We have the straight line like this. We have the circles. We have the circles like this. We have circles like this. So these are the circles. These are circles. These are the circles. We have circles similar to latitude. So these are the lines. We will get the circles, and we have the lines like this. 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 These are the longitude. These are the meridians running north south. So this will be 0, 1, 0 phase. This will be 0, 1, 0. This will be 1 bar 0, 0 phase. This will be 1, 0, 0 phase. And here it will be not 1, 1 phase. So if we take into account the net, Wolf net, so in Wolf net we see that it is like this. Okay. Generally a 10 centimeter radius is being taken to construct this net. So in net we will have these circles. This is equator. This is pole, north, south pole. This will be east, this will be west, and these are the longitudes. These are the longitudes. So this is the Wolf net, and this angle is 90 degrees. This angle is 90 degrees. That's why it is called equal angle net. Equal angle net, and this net is being used to plot the faces of the poles. Plot the poles of the faces. And how it is being done, that I will discuss. So Wolf net is being used to prepare the stereo diagram of the crystals. Normally this is a 10 centimeter great circle . 10 centimeter radius is 10 centimeter of Wolf net, where the great circles are phi angles and small circles are the rho angles. These circles are drawn at 1 degree or 2 degree intervals. This net is used as underlay because if this is the net, this is the net, this is the net, over which we place a tracing paper or transparent sheet and we draw this line, angular relationship from this net to this transparent sheet. This transparent sheet is called overlay. This net which is occurring at the bottom, it is called as underlay, and there is a central point where a pin is being used, thumbtack is being used, and this tracing paper can be rotated over this central point. This is required for angular measurement. So the net is used as underlay, and over it the tracing paper is placed as overlay to plot the poles of the faces. In order to plot the poles, the tracing paper is allowed to be attached to it, the underlay, through a thumbtack, which is a flat head pin at the center of the net, so that the paper can be rotated over the overlay. Then the outer circle of the stereo net is being drawn with markings on it, north, south, east, west directions. This circle is called the primitive circle. Let us know how rho and phi angles are plotted in this stereo net over the overlay. The rho angle of any face that projects at the center of the projection, that is at the location of the thumbtack, it is equal to 0 degree. Any face that lies on the outside perimeter of primitive circle, it has rho angle equal to 90 degree. Therefore, any rho angle between 0 to 90 is plotted outward from the center of the projection or away from the thumbtack location along the east-west or north-south direction. If a combination of rho and phi angle is such that rho angle is neither 0 nor 90 and phi angle is also neither 0 nor 90, the transparent overlay must have to be rotated about the center until the phi direction of the specific plane coincides with either north-south or east-west direction. Only then the rho angle can be plotted. So one example has been shown. Let us say a plane is having, a face is having phi angle 30, rho 60, and it is to be plotted on the transparent tracing sheet or on the overlay. So we have this is the net, underlay, over it we have placed the tracing sheet, we have marked north, south, east, west, and the outer circle is being drawn first to indicate the north, south, east, west point. Overlay was fixed on the net through the thumbtack at this. Here the thumbtack is being placed to keep in contact this tracing sheet over the net. The overlay was fixed on the net through thumbtack. North, south, east, west points are marked on the primitive circle. North, south, east, west are marks. Then point X is marked up for 30 degree angle clockwise to the south, because phi angle is 30 degree positive. So here it is 0, 10, 20, 30, 40. Here it will be 180. 10, 20, 30, 40. It will be 100 minus 180. So 30 degree. So this line is 30 degree. So this angle is 30 degree. But rho rho is given, this is phi angle. Phi we have phi 30, rho 60. Rho 60 means rho 0 is here, rho 90 is here, rho 60 will be somewhere here. So this point will have to be brought to the east-west line. The marked point x, which represents phi, the marked x point is brought over to the east-west line of the underlay by rotating the tracing sheet little towards north through the thumbtack. Then 60 degree is measured on east-west line, east of thumbtack, because here it is 0, here it is 90, so it will be somewhere here. So these lines, here we measure 60. So this point is the pole having phi 30 and rho 60. The point y, if this is point y, is the pole of the face having phi 30, rho 60. So we have to bring the phi point to the east-west line or north-south line. Then only we can measure the rho angle. If rho angle is 90, it will be on the periphery. If the rho angle is 0, it will be at the center. If the rho angle will be in between, it will be somewhere on this east-west line or in north-south line. So in order to plot this rho angle, we have to bring this phi into this line by rotating the tracing sheet over the thumbtack. Besides the above way of plotting the phi and rho for faces, the interfacial angles are also taken into account to plot the faces in the stereo diagram. For this purpose, the angle of faces are generally expressed with respect to 0, 1, 0 face or with respect to 0, 0, 1 face. So in my next class, I will discuss about how a stereo projection is being done by taking into account the interfacial angles or by taking into account the rho and phi angles. Thank you all for giving a patient hearing to my talk.